Hey everyone! Today I want to break down one of the simplest yet most important building blocks of modern AI, the perceptron. If you've ever wondered how a computer can think in the most basic way, this video's for you. Let's start with the big idea. Imagine a light switch that turns on if enough inputs are on. Like if enough people in a room clap, the lights turn on. The perceptron works a lot like that, except with numbers. It's the digital version of a single brain cell, taking in information, making a decision, and spitting out a yes or no. So what's inside a perceptron? There are three main pieces. First, the inputs and weights. Picture a row of dials. Each input, like x1, x2, x3, gets its own dial or weight that tweaks how important it is. If an input matters a lot, its weight is high. If it doesn't, its weight is low, or even negative. There's also a bias. Think of it as a stubborn friend who always tries to sway the decision one way or another. Next is the summation. The perceptron multiplies each input by its weight, then adds them all up, bias included. It's like stacking points on a scale and seeing which way it tips. The formula is simple. Z equals the sum of all those input weight combos plus the bias. But here's the magic, the activation function. In the classic perceptron, this is just a step function. If the result is higher than a certain threshold, usually 0, the perceptron fires and outputs a 1. Otherwise, it stays quiet with a 0. This turns all those messy numbers into a crisp yes or no answer, just like flipping a switch. Okay, but how does a perceptron learn? This is where things get interesting. Training a perceptron means showing it lots of examples, telling it what the right answer should be, and letting it adjust its weights and bias if it gets things wrong. Every time the perceptron makes a mistake, it tweaks those dials, making some inputs more important, others less. It does this over and over, getting better each time until it nails the right answer for every training example. This is called supervised learning, and it's like a student getting better at a quiz with practice. But, and here's an important catch, perceptrons can only solve problems where a single straight line can separate the answers. If you need something more complex, you need more layers. That's where neural networks come in. So, to sum it all up, a perceptron takes numbers, weighs them, adds them up, and flips a switch based on the result. It learns by adjusting those weights, one step at a time. Simple idea, powerful results. If you want to see how this works with real examples or code, let me know in the comments. Thanks for watching.